trying to do some kind of preparation. Okay, so let's get started. So thank you everyone for showing interest in this data center training class. I am Shudipto. You can call me Sudeep also. I have spent more than 25 years in this industry. Just like you all, I also, did graduation. And after graduation, I thought that by learning programming languages, I will get a good IT job. That was my mindset, just like you all. Okay. But very soon I realized that within 5 to 6 years of trying to land a good software job, I realized that that's something that's not going to help me out. And that's where, luckily, in the year 2005, after spending almost 6 years in software corporate training, I got a job in EMC. Okay, so that's since then I am into data center technologies, and I have done multiple large, projects uh, with respect to data centers across the globe. Many in India, of course, because I'm based out of Bangalore. But in countries like Sri Lanka, Bangladesh, Taiwan, Hong Kong, Australia, US, of course, then multiple parts of Europe. I have been involved in large, data center related projects in these countries. Okay, so whatever I'm going to, tell you in the class, it is one, of course, the concept and theoretical knowledge that we are going to focus on in the basic training for the first few days. But later, as and when we go along, uh, whatever I will be, teaching you, it is based out of practical, experience that I have faced, during implementations of such large projects which I was mentioning. Okay. So, and also during the course of my career, I have, touched upon various technologies, right from servers to storage to networking to backup to disaster recovery to virtualization to cloud and cybersecurity. Okay, so in the due course, phase by phase, I will be, teaching you all these, respective technologies. Okay, uh, I have no selfish interest. My only, I would be very happy if all of you get a job. Okay, that is the main aim. Okay, for you to become employable. Okay, and please feel free to ask any kinds of questions both during the training and after the training through the WhatsApp group. Okay. My number is there with you. I'll also share my email ID. Okay, you can reach out to me on LinkedIn also. If I am busy, I'll probably respond a little later, or we will take up those answers in the subsequent class. Okay, so we will have the classes from Monday to Friday, 8:30 a.m. to 10 a.m. Uh, I require only your commitment of time and whatever exercises or kind of, at the end of the class, whatever activities I'll be giving you, please do make sure that you put 100% effort in doing those activities because that is the learning. Okay. What I'll teach you in the class, you will probably remember a few percent of it, but when you're doing the learning activity and exercise, that is when most of the learning will happen because you're going to apply the knowledge. You're going to apply what you have learned in the class. Okay. So, please do take this seriously. And from a job perspective, I can be, you can be rest assured that once you have done these trainings, and a few maybe certifications, okay, definitely you will get a job because there is a huge dearth of data center engineers in the industry. Unfortunately, our engineering colleges and all, they do not recognize this gap in the market. Okay, and that is why I thought, let me start this kind of a training. Okay, so any questions before we get started? Any questions, any doubts? No? Okay, so let's get started. I'll be sharing my screen. Just give me a moment. You all can see my screen? Hello?
Yes, sir.
Okay, thank you. Okay, so let's get started. So, first thing, what we are going to talk about today is about data. Okay, so can one of you define data for me? Whatever you have learned in college or whatever you may have learned from anyone else. Okay, what exactly is data? Anyone? It's okay, there's no right or wrong answer here. You can feel free to express yourself.
Hello, sir.
Yes.
Yeah, it's good to hear you there.
Yeah.
Uh, I may
What do you?
be right or wrong. Data may be of any kind,
Mm-hmm.
like figures, audios,
Mm,
videos,
mm,
or any kind of information
right.
that can be stored or shared to anyone.
Hmm. Perfect. Perfect. That's
Yeah,
exactly right.
thank you.
And your name? Your name?
Chandra Prakash.
Hi, Chandra Prakash. You're
Yeah,
very right. That's exactly what we mean by data. Okay. Any kind of digital information that is stored on any kind of medium or tool or app. Okay. We will define it as data. Now, why is data so important? So, data has become the new oil. Okay. So, to all these years, nations were fighting over, precious natural resources like oil. But now the fight is not over oil, the fight is over data. Okay. Whoever has control of data, they are going to be the most valuable. Okay. Now, what are the sources of data generation? Okay. And we will also see a comparison of what are the magnitudes of data or volume of data that we are talking about, which needs to be handled. Okay. So these are some of the examples of sources of data generation. Okay. Whenever we use our smartphone, okay, we are generating data. Whenever we are taking pictures or videos, we are generating data. Whenever we are doing any financial transaction in a bank or stock market or mutual funds, uh, or taking loans or using credit cards, we are generating data. Whenever we are going to a hospital, our patient records, our diagnostic reports, okay, all that is data. Whenever we are, taking any medicines, there is enough amount of research that goes behind bringing out a validated medicine in the market. So all that is data. Whenever we are using any kind of AI tool, we are giving it prompts, we are giving it our access. So all that is data. Okay. So data generation and storing happens all the time, 24/7 across the globe. Okay. Now, moving forward. When we are on a laptop or using our phone, okay, the amount of data that it gets generated is only in GBs. Uh, is only in GBs, right? So we use SD card, we use our laptops, hard disk, okay, or SSDs, okay. All of these are measured only in GBs, okay. But when we go to data centers and when we talk about, these big companies, okay, who are running and using these data centers, what is the volume of data that we are talking about? We are talking not about GBs, not about TBs, but we are actually talking about petabytes, exabytes, and zettabytes. Okay. So you may all know the metrics, right? So first is 1 byte. Okay. Before even that, 1 bit, a zero or a one is called a bit. 8 bits forms a byte. Okay. 1024 bytes becomes 1 kilobyte. 1024 kilobytes is 1 megabyte. Similarly, 1024 megabytes is 1 gigabyte. 1024 gigabytes is 1 terabyte. Then 1024 terabytes is 1 petabyte. Okay. I will give you a small example. Uh, how many of you have seen the movie Avatar? The Hollywood movie Avatar? I think three versions have come out, right? Avatar 1, 2, and 3. How many of you have seen it? Yes, great, great. Thanks, Prakash. Yes, Anand, thank you. So, my next question is for when you're seeing that movie, let us say you have downloaded. Yes, Shivani, thanks. When you're downloaded that movie, let's say on your laptop or using BitTorrent, how much amount of data it occupied on your phone or laptop or things like that? Any idea? Let's say it is full HD 4K resolution, okay, and um, maybe you're using Blu-ray disc also, okay. So how much amount of data do you think that movie would have occupied in your device?
Ranges between 5 GB to 8 or 10, sir.
Perfect, yes, okay. But now let me tell you this. You know how much amount of storage is required to make just 20 seconds clip of that movie? Any guess? So let me tell you.
500
There is
GB.
500 GB. Okay, good guess, good guess. Any other guesses? Any other guess? Okay, let me tell you the scale. So there was a company called Technicolor, which does most of the VFX for most Hollywood movies. They were my customer, um, and they are there across the globe. Uh, just for Avatar movies, 1 20-second clip, in order to do the complete VFX graphics for it, they needed 45 terabytes of storage space just for 20 seconds. So imagine how much a 3 hour movie would need in terms of storage space inside a data center to do the complete production. Okay, so that's the scale of data that we are talking about. Okay, when you're watching a movie or video on YouTube or on Netflix or any of these OTT platforms, for you it's only few MBs or GBs. But in the backend, when the designers are actually working on that video to make it consumable content, it ranges into terabytes and petabytes. Okay, now all that data needs to be stored, needs to be secured, needs to be backed up, needs to be handled. And this is the technology, or this is the range of technologies that we are going to learn in our sessions. Okay. So the amount of total data inside the world is actually humongous. Now, why should one care? Okay. Or what are the typical problems a company faces with respect to data storage and handling this data? So the first question that companies have in their mind is with respect to handling the capacity and the performance whenever they need it. Okay. So let's say a new project is coming. That new project needs a few hundred terabytes worth of storage. Okay. Now, we do they have so much in their data center, or do they need to buy additional, hardware, or can they get it on cloud? So these kind of questions will be coming to the mind. Second thing is when people or end users are actually working, when engineers are working on that data, is it very slow, or is it, is the performance acceptable? So how can we design an architecture which gives, the best performance? So that is another thing. Then when it comes to the business side of things, right? People who are making these investments, who are buying this costly equipment, okay, and the software, how will they get return on that investment? That is another, very important question. And lastly, for engineers like us, right? How can we reduce the downtime? How can we make sure that the systems are always up and running? Okay. For example, all of you have bank accounts, right? Will you accept that the bank comes and tells you, "Oh, I'm sorry, Miss Shivani, Mr. Anand, Mr. Prakash, your bank account will not be accessible for 10 hours today." Okay. Will you accept it? No, you won't, right? Because you're paying them an annual fee. They are responsible for storing and keeping your money safe, and you want the freedom and flexibility to access and use that money whenever and wherever you want, right? And which means that all these kinds of data and services should be always on and always available. And you will see in due course that it is easier said than done. Okay. A lot of complex operations and architectures are required inside the data center to make this happen. And that is exactly what we are going to learn phase by phase. Okay. Moving forward. So what we are going to start with is on data storage. Okay. So we are going to talk about certain key concepts in the data storage industry. Okay. Then we are going to, talk about some additional reading material which I'm going to share with you either on WhatsApp, okay, or directly over email. This additional reading material I want you to learn and read after, everyday class. So what we are going to learn is identify the key components inside an IT infrastructure at a very high level. Then we are going to understand how storage works. What are the various components of a storage system? Okay. We are going to discuss the various kinds of networking technologies involved in accessing the storage systems. And we're also going to learn how storage is there on the cloud, what exactly is cloud, and how people use cloud, how companies use cloud. And we will also learn about how to protect the data inside the storage system. Okay. Why we need to protect? You all know that cyber threats are there. Then many components of a system can fail at any given point in time. You never can predict it. So, irrespective of what kind of failure, irrespective of what kind of threat, data should always be available and should always be accessible, and there should be no loss of data. Okay, so we are going to understand how we are going to achieve this and what kind of technologies are available today for us in order to achieve these things. Okay, At any point of time, if you feel you're not able to understand something, please raise your hand or please interrupt me. I will stop and we will clear your doubt and then move forward. Okay? Please feel free to pause me wherever you feel I'm going fast or you're not able to understand. Okay? All right. So now moving forward. So we are going to, in this lesson today, we're going to talk about what is binary code, uh, and what are the various media types available, so on and so forth. Okay. So many decades back, uh, people found out a way uh, to work with things called transistors, which were originally used in radio equipment and later got started using in computers. Okay, they are called transistors. Now, what's exactly a transistor? A transistor is a small electrical device which can hold a charge. Okay, whatever be the amount of charge, it can be 0.1 volts, it can be 2 volts, like that, small amount of charge. Okay, and what people did, scientists did, is they built certain sensors which can read whether a particular transistor is charged or uncharged. Okay, if a transistor is charged, then they will treat that as 1. If the transistor is uncharged, then they will treat it as 0. And thus was born the world of digital computers. Okay, using very simple transistor technology and certain sensors, we were as humans able to build computers and systems which will understand what is a 0 and what is a 1 and use that to either store information or deliver information. Okay, so that slowly we started to understand it as binary code. But at a low level, what is happening is just we are using transistors, okay, at the electrical and electronic level, nothing more than that. Okay, so a series of zeros and ones gets converted to, the human readable language in English. Okay, and now, so it can be converted in various other languages also, but first they, for many decades they did it only in English. Okay, and they developed a particular, I would say, language translation code called as ASCII, ASCII, ASCII. Okay, ASCII, ASCII. So ASCII is the way in which you can convert a binary code into a human readable language. Okay, so for every letter of the alphabet, for every symbol, for every number, there was a decimal number attached to it, and that decimal number would get converted into a binary code like this. Okay, so that code conversion is done using something called as ASCII. Okay, so you might have learned all this during your engineering or graduation, but this forms the basis of data storage. Okay, we need to understand this very carefully. Moving forward, what are the different types of data that is available out there and how people actually store and treat this kinds of data? So we are going to understand this, and this, why it is very important to understand these types of data, because both of these data types are treated differently. Okay, so when you want to store it, it is different. When you want to access it, it is different. Okay, so why it is different, I will explain. So broadly, there are these two categories of data. One is called as structured data, and the second one is called as unstructured data. Okay, so what is meant by structured data? Everything gets stored in a proper predefined format. Okay, where the format has been predefined. Okay, if you are storing the data in that kind of a fashion, then it is termed as structured data. Okay, some examples are the data that gets stored with respect to your bank transactions, anything that gets stored as a database. Okay, like your ticketing information, flights and travel, then banking or financial related transactions, then your health records. Okay, your school or college, state mark sheets or statements. Okay, all of these are stored and maintained in a predefined and a structured format, basically in the form of databases. Okay, you might have heard of Oracle, you might have heard of SQL, Microsoft SQL, MySQL, Postgre, DB, Cassandra, MongoDB. These are all examples of databases. Okay, so in a database, the data is stored in a predefined format. Okay, and the way we treat it will be different. I will tell you why. Then the other category is unstructured data, where we are not storing the data in any predefined format. Okay, we are just storing it as and when we need it, as and when we want it, and as and way when we use it. Okay, like all our videos, photos. Okay, whenever you are submitting your KYC documents, uh, like Aadhaar card, PAN card, and all. Okay, all those will form as unstructured data. Okay, and unstructured data is stored as simple files, okay, or objects. They are not stored in databases. Okay, so this is the primary, characteristic of these two kinds of data types: structured data and unstructured data. Okay, now there is also a huge differentiation in the way structured data gets accessed and how unstructured data gets accessed. Okay, structured data gets accessed very frequently, and the expectation from end user is the data should be available instantaneously. Okay, within whenever you click, whenever you request, the data should appear in front of you instantaneously, right? So for example, whenever you log into your bank account, all your financial transactions should appear instantaneously. There shouldn't be any delay, right? And you can do any number of financial transactions in a given day, right? And imagine a bank like HDFC or an ICICI bank. They have millions of customers across the globe. Okay, all of them 24/7 are accessing their websites, are accessing their accounts all the time, doing transactions. And for each and every individual and for each and every corporate, the data should always be available, and the data should be served instantaneously. Okay, there shouldn't be any delay in providing that data to the end user. Okay, so that is a very important factor, because you see these few things, right? One, data of structured data should be available 24/7. That means always on. It can never be off. And second, very high requirement in terms of performance. Okay, sub second, which means millisecond to nanosecond kind of performance is required whenever you're trying to access any structured data. Okay, and that to the end user should be available instantaneously at the click of a button. Okay, that's the expectation. But when it comes to unstructured data, one, there is no specific pattern. Okay, any user can request any kind of data, okay, from any kind of platform. Like when you want to see a video, either you can go to YouTube, you can go to Instagram, you can go to Facebook, wherever that video is uploaded, right? So there is no predefined pattern to accessing that data, right? And second thing is the users are okay even if there are a few seconds of delay in getting that data. For example, a video that you're watching on YouTube, even if there is like a few seconds of buffer, you will be okay, right? You will not close YouTube. You will still watch that video, you will still enjoy that video and consume the content. Okay. Similarly, whenever you want to download your e-ticket, or you want to download your mark sheet, or you want to upload some kind of KYC document to a bank, even if there is a few seconds of delay, you are okay as an end user. Even the bank is okay. Okay. Suppose some medical records are there. If your patient record or medical record is not getting downloaded instantaneously and there's a few seconds of delay, you still are okay, right? You will not complain. So that's the nature of our expectation with respect to unstructured data, right? Little amount of delay is fine, and at the same time, we are not accessing that data in a predefined format, and there is no specified pattern with respect to that kind of data, right? So any questions on this classification? Because this is the foundation, boys and girls, of understanding data storage. Any questions, any doubts? Okay, moving forward then, if there are no questions or doubts. Okay, now we talk one step ahead. Okay, we have understood what are the different kinds of data. Now we have to understand what is meant by a workload, because when you get into a data center job and when we are dealing with a customer, or you're working, okay, at any particular company, you will not talk in simple terms like, okay, give me this data, give me that data. You will actually talk in terms of a workload. So just identifying this term and knowing when to use it, in what context to use it, will help you. Okay. So what is a workload? A workload is any kind of a task or a job, or even a software program, or even a script, okay, that needs to be run on a certain server or a computer, which involves some amount of processing of data in the backend, either unstructured or unstructured. Okay, uh, that is called as a workload. Okay, like for example, your IRCTC website when you're booking a ticket. So that's a workload which involves a web portal or a web page which is accessing some kind of database in the backend to store your data and fetch your data, right? So that's a workload. So it's called as a web workload because it's run on a web page. Similarly, when we are talking about emails, emails are incorporate specific to a particular company, right? So that email application becomes one workload. So any new email that you're sending, that needs to be stored for X number of years. Any email that you're receiving from within the company or outside the company, that also needs to be stored and kept for X number of years. Okay. So email or mailboxes becomes one kind of a workload. Okay. Then we use a lot of apps. We use OTT platforms. We use, okay, these payment apps, UPI apps and all. So whenever you're making a transaction, you're generating data. Whenever you're seeing your history, you're accessing data. So that app itself becomes a workload. Okay, because that's the software program which is actually helping you to store data and to access data. Okay, so it's an application, we can call an application workload. Okay, then there are other specialized software available in the industry today, which will do processing of not just a few bytes, few kilobytes, or few gigabytes, but terabytes and petabytes of data at once. Okay, so those kind of software are called big data workload. Okay, these are used by large AI algorithms. They are used by very large companies in the backend to do mass data analysis, or to do AI training. Okay. When I say AI training, not training the individual, but training the AI algorithm. Okay. So those kind of workloads are called as big data workloads. And in our advanced training, we will learn little bit about that also. Okay. Any questions? Any doubts? Okay. Moving forward. So now we talk about data center infrastructure. So we will learn what exactly is a data center, what are the various components inside a data center, and we'll just do a small knowledge check as to how much you have learned. So, how many of you have ever visited a data center? Can I show a raise of hands, please? How many of you have ever visited a data center? No? Okay. How many of you have seen physically any kind of data center equipment like a server or a switch or something like that? Bhanu, this is not for you.
Yeah, sir.
Okay, Chandra Prakash, you have seen. So, Chandra Prakash, so can I call you Prakash? Hello?
Yes, sir.
Yeah. So, the first time I stepped into a data center, I was awestruck. Yes, Anand, tell me.
I have also seen in National Atomic Research Laboratory, sir, during my college days, sir.
Wonderful,
They have
wonderful.
showed us, sir, a data center like this.
Hmm,
They're they're having big computers. They
hmm,
have
hmm.
shown us, sir.
Excellent, excellent.
During industrial visit. They have showed
Okay,
us.
okay. All right. So, for those who are in Bangalore, I will try to arrange a data center visit for you, okay, through my connects. Uh, and for those who are not in Bangalore, who are in, let's say, Hyderabad, Pune, Mumbai, whenever I am visiting, okay, we will try to catch up, and I will try to, show you a data center, okay. Because unless you see it, unless you touch and understand how the various components are interconnected physically, it is very difficult to comprehend the scale and appreciate the scale at which data centers are operated. Okay. And I feel lucky and fortunate to have seen very, very large data centers and have worked in setting up and operating multiple large data centers. So I feel lucky, but the same experience, I will see how best I can share with you also. But for now, let us try to understand what's inside a data center and what are the various components in it, and how these components talk to each other, how they interconnect with each other, what is the role of each of these components, and what is involved in setting up and smoothly running each of them. Okay. So these are the few very critical components inside a data center. They are divided into three parts. From right to left: storage, network, and compute. And for these to work properly, you need a proper power supply, proper environmental control, that's very, very important, and physical and cyber security. Okay, that these are also very important, and we will see why. So these six things or these six components make up the complete data center. Okay, once again, storage, network, and compute, these are the actual equipment that are storing and processing data. But for these equipments to work properly and optimally, you need proper amount of power supply. You need ambient temperature with almost zero dust and zero humidity kind of an environment, because these are the two critical factors. Okay, dust and humidity, they are the biggest enemies for any electrical and electronic component. Okay, if you are operating data center or any kind of a electronic equipment in a very humid environment or in a dusty environment, they are bound to fail much quickly than what they are designed for. Okay, and then physical security as well as cyber security. Okay, why physical security? Many of these components inside a data center, for convenience, they are plug and play kind of components. That means anybody who has physical access to the data center can connect a network port, can remove a network port, can connect a hard disk, can remove a hard disk. Okay, uh, some other components also, which are called as FRUs, field replaceable units. Okay, they can be removed and new ones can be plugged in. Okay, so uh, these things were actually designed for convenience so that it is easier to maintain these systems, but over a period of time these have become vulnerabilities, and hence a physically secure environment is also required to run a data center. You should not allow unauthorized personnel to just walk in. Okay, because they can create havoc inside a data center. uh, some things are not mentioned here, but those are also very important. So for example, fire suppression, that is also very important component of running a data center, because a spark or a fire in one small component due to any kind of a power leakage or wrong thing with power can lead to a widespread fire inside the complete data center. Okay, that may lead to loss of property, loss of data, and loss of human life also. So fire suppression is equally important. Okay, and another thing that is very important is rodent protection. Okay, I have seen multiple times that rats and insects become a huge problem inside a data center if not handled properly. And you may think, wow, does is this a reality? I will tell you, yes, 100% it's a reality. Okay, whenever I show you the data center, you will see there are facility management people who are putting traps for rats, then who are doing pest control also in the data center, because rats can chew away the power cables and network cables. Okay, and that can lead to disruption of handling the data. Similarly, small insects, either flying insects or crawling insects, if they get into the data center equipment, they can also create havoc, and they can lead to the improper functioning of the equipment inside a data center. So apart from these six things that are mentioned here, these other two things called fire suppression and rodent and insect handling, okay, these are also very important aspects of running a data center, though nobody talks about it. Okay, moving forward. Yeah. So this is a very high level diagram of what are the key components within a data center and how are they interconnected with each other. Okay. Again, starting from right to left, the first component is that of a storage system on the extreme right. So storage systems are very large equipment which are going to allow you to store, protect, and process, petabytes of data. Okay. But these storage systems do not have the capability to run workloads. What are workloads? We have seen earlier, right? What is a workload? This is a workload, right? So a workload is nothing but a program. Like a database is a workload, like a web server is a workload, okay? Like a app is a workload, right? Now, these storage systems, they do not have the capability to run a workload, okay? Which means they are a single purpose machine, okay? Their only purpose is one thing. That is what? To store data and serve data. That's it. They cannot do anything else, okay? And hence you need other systems in the data center which will actually allow you to run a workload or run the programs actually, okay, or the software. So those components which will allow you to run the workload or the program or the software or the app, those are called as the servers, which you see on the left. Okay. So a storage system is a single purpose hardware which has its own software, but this hardware and software combination has ultimately a single purpose only, that is to store and protect data. That's it. It does not have any other purpose. It cannot do any other thing in the data center. Okay. It can only store and protect your data. That's the role of a storage system. And hence, you need separate hardware inside the data center, which will allow you to run a workload. A workload means a program, a software, an application, an app, a database. Okay, all these things are called as workloads. And the machines on which workloads are run are called as servers. Okay, now these servers, they can run the workload, but they do not have the data. On the other hand, the storage system has the data but does not have the capability to run the workload. Now, both these need to talk to each other for the end user like us to work with the data, right? Hence, you need to connect both of them. Now, how will you connect both of them? You will connect both of them through a network. Okay. And that's why the networking between servers to storage systems becomes another very critical component of building and establishing and running a data center. Okay, so let me repeat once again. On the right hand side, you have single purpose hardware and software systems put together. They are called storage systems. On the left hand side, you see servers. The role of the servers is to run workloads, applications, databases, web servers, so on and so forth. And the way servers get connected to storage systems is through a network. Okay. And these three components put together form the active components within a data center. Okay. Any questions? Okay. No questions. Let's move forward. Right. So we're going to talk about two different examples here. Okay. So we are seeing here an example where we have two data centers. Let us say one is in Bangalore and the second one is in Mumbai. Okay. We should also have mechanisms in place where if a complete data center goes down, okay, that same data, that same application workload should be accessible from another data center, but that data center could be miles away. Sometimes it may be in another continent also. Okay. So this is called as disaster recovery. Okay. Or some people also call it business continuity. Okay. Both mean the same thing. Let me give you an example. A few years back, if you remember, there was a huge flood due to torrential rains in Chennai. I know people from Mumbai, Renu, Shivani, they will know this, that whenever there is huge rains in Mumbai, there is flooding that happens, right? And the first thing gets impacted when there are floods, when there are rains, is what? Power, correct? And what happens when there is no power? How will your data center operate? So during those Chennai floods, I have personally seen data centers get flooded. Okay. Now, how will that business survive if their data center is flooded and no longer operational? Okay. That is the reason why people have developed and they also use something called as disaster recovery technologies. Okay. DR in short, which will make sure that whatever data is there in your first data center along with your workload, okay, that same is getting replicated on the fly over a network to another surviving data center, so that whenever a disaster strikes in one data center, automatically, the users can start accessing the data from another data center. Okay. Another example that I can give is recently you would have seen earthquakes happening in Malaysia and Thailand and Myanmar, right? And when such earthquakes happen, even the buildings that are storing and housing the data centers, even they will get impacted, right? So how will the banks that are running in Malaysia, how will the hospitals, how will they survive if that data and those systems are not available? They will always have a DR, disaster recovery data center, somewhere else, okay, at an undisclosed location, and they will start operating from there, right? So here is one more example of my experience that I wanted to give you. Uh, uh, all of you know BSNL, right? So I was one of the engineers who set up huge data storage systems for storing call data records of BSNL. Okay, this was way back in the year 2011. Okay, so me along with my teammates, we were sent to multiple sites of BSNL where they have large data centers, and every call that used to get made through the BSNL network, the respective details of those calls need to be stored real time and needs to be replicated to three different data centers simultaneously, so that even if one data center would fail either due to a natural calamity or due to loss of power or loss of internet connection or anything of that sort, automatically the all that data will start getting stored in a surviving data center in another city. Okay. Similarly, very large banks like Citibank. So I also did some work for Citibank. Citibank has at any given point of time your data, that means end user data, stored in 7 different data centers across the globe. Okay. And two of those data centers will be in remote bunkers in deserts. Okay. So that they have a golden copy which is not affected by any kind of a natural calamity or disaster. Okay. So how we achieve this, we will learn later. Okay. But such technologies are available, and What you're learning now is going to form the foundation for you to be able to build and architect such solutions in the future. Okay. So don't think that what you're learning right now is irrelevant. Definitely not. It is very, very relevant, and it is the need of the hour. There are very few people in the industry today who can actually, do this, and you will become one of them in the next few years. Okay. Any questions? Okay. So here we are doing a little bit of more drill down into how end users access the data from outside, okay, over the internet to the data which is getting stored inside a data center. Okay, so that is where we define these various components. Okay, so the first component is called, so let me go back a little. Yeah, so let us understand this diagram once. So these components, the server 1, server 2, and the storage system, we have learned a little while earlier that these are the components that are stored inside a data center. Okay, but they are inside a data center. How will end user like me and you access those data that is sitting inside the data center, right? So that is where these servers get securely connected to the internet. Okay, so what are the mechanisms used to securely connect servers to the internet? We will learn later during our networking module. But this is a very high level and simple representation of how it happens. So the server which are hosting the application or the workload, they will get connected to an external network. Internal network is called as LAN, local area network, and external network is called as WAN, wide area network. Okay, which you see on the right hand side inside the cloud. Both of them get connected through a router. Okay, so how can I give you a very simple example of this? Let us assume that you have multiple phones and laptops in your home, right? Your laptop and your phone is getting connected over Wi-Fi to that Wi-Fi router. Okay, and that Wi-Fi router, you will see from behind, has a cable that gets connected from your house to somewhere outside, and that is your connectivity to internet, right? So this Wi-Fi within your house, that can be called as a LAN within your network. That device to which you are connecting using the Wi-Fi access point, that becomes your router, and that cable that is going from the Wi-Fi router to your internet provider, so that is your connectivity to internet. So just bring that same thought process, that same analogy or example inside a data center, right? So these servers are connected to an internal network called as LAN. Okay, and these servers via a router get connected to the internet securely. And that's how, when we type a web address like irctc.com or makemytrip.com or something else, okay, .com, all right, that HTTP request or that web request which you're putting in the browser over the internet goes and lands at one of these servers inside one of the data centers securely. And that's how we see whatever information the servers are pushing to us over the internet. Okay, any questions on this? Hope you all are able to understand. Is it getting too complex or too boring? You let me know. Okay. Now we will drill down into each one of these components. Okay. So the first critical component that we are going to drill down is the server. Okay. So what exactly is a server? The simple analogy of a server or a compute is that of a human brain, right? So we know that our human brain controls all our actions, right? All the processing is done in our brain with respect to data that we receive from our senses, and data that we want to give out from our memory. All of that processing is happening in our brain, right? Similarly, the servers or the compute, okay, become the brain of a data center. They are the ones who are responsible to do all kinds of calculations, all the permutations and combinations on the data. Okay. The second component is like the network. It's like our nervous system. It is the one that connects various components to each other, right? It is the one which is responsible for securely transferring the data from one component to another component, however big or however small. Okay. And there are various components that form a network, like a switch, a router, an access point, then the physical cables themselves, so on and so forth. Okay. And then comes the storage system. The storage system is where the data gets stored permanently. Okay. Why do I stress upon the word permanently? Because even if there is loss of power, okay, even if there is loss of power, data in a storage system will not get lost. Okay. It will remain in the storage system even if there is no power. That is the role of the storage system. Okay. I can give you a lot of examples. First example, um, in our childhood days, we used to use audio tapes. Okay, that time smartphones were not available. And even if there is no power, whatever songs I recorded on that audio tape is still there on that audio tape, right? You only need a player to read the data from the cassette. Okay. Similarly, in today's world, when you're using an SD card, okay, to store all your photos, your videos, and everything, as long as the SD card is connected to your phone or your laptop, you are able to read and write data into that SD card. But when you remove the SD card from the system, does it mean that the data that is there on that SD card is lost? No. And when you're holding the SD card in your hand, there is no power to that SD card, right? Still, all the data that you had written on that SD card is there. It is available. Only you have to put it into a system to access it. Similarly, as to whatever you store in the data center's storage systems, that data should and will be available even if there is no power. Okay, so which means it is like the uh, place where data gets stored permanently and persistently. Okay, so in human terminology, you can call them as the neurons, so which we use to store information, right, like our memory. So that is the role of the storage system. Even if there is no power, still the data will be there in the storage system. Okay, now a question for all of you. Please write your answer in the chat box. Let me see how many of you get it right. Which of the following is used to provide data, information, or instructions to run an application? First answer, persistent storage. Second is server. third is network, fourth is client. Which is the right answer? Can you put it in the chat box? Okay, Jagdish, Renu, Anand. Okay, how about others? Prakash, Bhanu, Shivani, Gopi? Yes, correct. Yes, that's the right answer. Correct. Yes, server is the right answer. Correct. Okay. Now, in the next, I'll do one thing. I think we'll pause for today here. Okay. Because the next topic requires, uh, a continuous stream of thoughts. Okay. So I just wanted all of your feedback on this first class. You let me know whether it was good, anything needs to be improved. Okay. And I will also give certain tasks, learning tasks to do. Okay. In the WhatsApp group. Okay. Give me some time and I will put that. Okay. There was a question. May I know the total duration of this course? Uh, Prakash, I plan to continue this course for months together because all the topics that I plan to teach you all cannot be completed in a short period of time. Okay, if you have to learn it properly with examples, with practicals, and all of that. Okay, so that's why we will take it slowly and we will increase the pace after a certain weeks, after a few weeks. Once we both understand each other pretty well, once you all are comfortable with data center terminology, you know where to find information, you know how to use that information, and then parallelly you also start understanding what kind of jobs you should be looking for out there. Okay, so until you reach that stage we will go a little slow, but once you all reach a certain stage we will pick up pace and we will start doing things at a much faster rate. In these first few days we will concentrate more on learning the core concepts. So it will be more of reading, learning, and understanding. But after the basic course is completed, when we get into the intermediate course, there will be hands-on labs that I will ask you to do, and I will ask you to show me how you have performed in a lab, in the lab environment. Okay, so hopefully we should be able to complete these concepts within the next 2 weeks. Okay, that means hopefully by end of April all of us will come to a stage where we understand the core concepts pretty well, and that is when maybe from first week of May onwards we'll start getting into doing things practically, right? In a kind of a lab environment. Okay, so as of now your laptops are good enough, you don't have to buy anything, you don't have to purchase anything. Okay, I will tell you exactly how to set up a lab, and I'll give you lab exercises and lab manuals and worksheets. Okay, you can just follow them so that you can practice well, and as and when there is an opportunity for me to take you along to any particular live data center related work, I will call you. And if you are there in that vicinity, Bangalore, Pune, Hyderabad, or any other place, we will go together, and you will get a practical hands-on experience of how real world data center technology is done. Okay. Any questions other than what Prakash has asked? Yes, Anand?
Uh, Sir, does internet speed play any role in data centers, sir? I heard that internet speed will be in gigabytes level per second. Is that right, sir?
Oh, yes. It plays a very, very important role, especially for workloads and applications that are internet facing, like the examples that I've taken, right? Like IRCTC website or your bank website. Okay. So, what is the data center internet connectivity? That plays a very important role. And yes, the internet speeds go into gigabytes per second, and there's always not a single connection. There are multiple connections that are coming in from multiple networks and service providers to a single data center. Okay. And there are different kinds of internet connectivity also. What we use in our homes is called as shared bandwidth, and that's why it's called broadband. Okay. But what gets used in data centers is completely different. They are called MPLS links or point to point links. Okay. They are dedicated high speed networks for data centers. Um, and we will also see how uh, um, internet gets connected. Okay. Uh, it is not over Wi-Fi. Okay. Their internet is formed actually through cables, and all these cables are running in our seas and oceans. Okay. Undersea cables are the backbone of internet, and each and every data center in the world, in one way or the other, is connected to the internet through these cables that are running in our seas and oceans. Okay. So we are all interconnected to each other. Even when we are speaking right now, some amount of our data is going through some, cable which is lying under the sea. So yes, that is correct, Anand. Jagdish, you had a question?
Thank you, sir.
Yes.
Yes, sir. Sir,
Yes,
you
Jagdish.
tell about the disaster recovery, right?
Hmm.
But my question is, our data center is in different places, it
Hmm.
was affected by one place.
Hmm.
But how much time how the data is transferred? Like for every one day it will take to transfer, or every 1 hour or few hours for every month? I have a doubt on that. Can you tell me, is there any scenario like that it will occur?
Oh, yes, yes. Uh, this is actually a disaster recovery concept. And when we are learning disaster recovery, we will learn about concepts called RPO and RTO. Okay. Where RPO stands for recovery point objective and RTO stands for recovery time objective. And we will talk about specialized software and network architecture that is required to do this data and workload replication from one data center site to another data center site over the internet or over a dedicated link. Okay. But that's in order to understand how disaster recovery works, you need to first understand how storages and compute work. Okay. So that's why we will take this up at a later stage. Definitely, it's part of our module and the course. And the frequency with which we transfer the data, it changes. It changes, and it is customizable and configurable actually. Okay. So when that time comes, I will explain with actual, practical scenarios, um, uh, and practical examples which I have implemented hands-on at various customer places. Okay. So yes, that
Okay,
definitely
sir.
is something that we
Thank
will
you for the
learn.
information.
Yeah. Yeah. Any other questions? Okay.
Sir, I saw
Yes.
long
Yes,
back
Gaurav.
ago post on underwater data centers of Microsoft.
Yes.
Yeah, why is only the that big company is there? and there are no other companies like that where they have underwater data centers. Why
Very
is
good
like that?
question. And Prakash, I'm very glad that you read a lot about data centers. That's really good. Okay, so um, if you saw our first few slides, I told you that one very important factor was power for a data center, right? Now, this power is required for two things. The first thing is to actually power on all the equipment like the servers, the storage, the networking equipment, the routers, the various sensors, the fire suppression, all of that. But another significant portion of the power is used to keep the systems cool at an ambient temperature. Okay. The ambient temperature of running a data center is somewhere between 18 degrees centigrade to 22 degrees centigrade. Okay. And what happens is these large data center equipment, the more you use them and the more aggressively you use them, okay, they generate that much amount of heat. And this heat has to be properly, managed and controlled. That means the cooling system should be such that the heat doesn't get trapped and the heat has to flow out in a very proper manner. So that's why in data centers they create things called cold aisle and hot aisle. So cold aisle is the place through which cold air is pumped in to the data center, and hot aisle is the place from where hot air is sucked out of the data center. Okay. Now all this happens through very complicated HVAC systems, high volume air conditioning systems. Okay. And these systems need huge amount of power. They are very power hungry. That's why you will see on the terrace of many data centers, you will have chiller plants, okay, which are constantly recycling hot water into cold water, okay, to keep the entire data center at ambient temperature. The percentage of power required just to cool or keep the data center equipment in ambient temperature is anywhere between 25 to 40% of the total power requirement, which is huge, isn't it? So, for example, if a data center needs 10 megawatts of power, out of that 10 megawatts, 3 to 4 megawatts is for cooling the entire systems itself. And unfortunately, today we do not have very efficient cooling mechanisms. Okay, so the Microsoft's undersea data center is an experimental concept where they are trying to see if they can reduce the need for cooling by placing the entire data center equipment in a concealed container or a chamber under the sea, because naturally it is cold under the sea, isn't it? The temperatures are sometimes very close to zero and obviously less than 10 degrees centigrade. Then you don't need a chiller plant, you don't need to create hot aisle, cold ice, don't need to create these very complicated cooling mechanisms, and hence the requirement of power comes down by 30 to 40%. So that's a big achievement, okay, if it can be operated at scale. So right now, Microsoft is experimenting by doing this at a very small scale. And if it is successful, they are going to expand it to a larger scale. Okay. But having said that, new kind of cooling mechanisms are coming in. Okay. They are called as liquid cooled systems. Okay. And hydrogen cooled systems. So we'll talk about them a little later. But just to give you an idea, today all the equipment in a data center is placed like this horizontally. In the front you will have cold air intakes, and in the rear you will have hot air blowouts. Okay, and what is happening right now is in the liquid cooled data centers, all the equipments are actually placed like this, okay, vertically, and they're actually dipped into cold liquid. Yes, the server storage systems are actually dipped into and kept in cold liquids. Okay, and these liquids are not water. Okay, so there is no short circuit that's going to happen. They are dipped in a oil kind of a liquid. Okay, the special liquid whose boiling temperature is way high. So when the equipment comes in contact with the liquid, it doesn't stick to the equipment or it doesn't cause any short circuit, but it helps to radiate the heat outside. Okay, so liquid cooled data centers are the next thing that is coming up in the market. Still, it has not been adopted much because people have not understood the risks and what is required to maintain this liquid cool system. So that is also happening in small patches at this point in time. Still now, by and large, the entire world, across the world, data centers are cooled using normal HVAC, which is air cooled systems. Okay, so cold air blows in, hot air blows out. Okay, so that's typically how it is happening today. Okay, so we'll learn more about it. Uh, but to be very honest, that is not our core job. Okay, that job is taken care by the building facility management. Okay, who are responsible for power, cooling, fire suppression, and all of those things. Okay, so typically cooling also becomes a deliverable of those people. But just to let you know, every data center component, just like how it will have its power rating, similarly it will have its heat dissipation rating also. How power is measured in volts and watts, heat is measured in BTU per hour. BTU stands for British Thermal Unit. Okay, BTU per hour. So every data center equipment will also have in its technical specification sheet what is the BTU per hour, British Thermal Units per hour. That means how much joules of heat is it going to generate per hour, and this information is required by the building management systems to design the amount of cooling capacity required. Like for example, when you buy an AC, what is the first question the sales guy asks? Sir, how many tons of AC do you require? 1 ton, 1.5 ton, 2 tons, like that. What exactly is that? That means what is the volume of your room? So how much amount of cold air is required to keep that entire room cold? Okay. Similarly, this BTU per hour rating of a device is used by the building management system to understand how much amount of cooling capacity is needed to cool that equipment. Okay. So whenever we are building a data center or a rack full of data center equipment, not only should you consider the amount of power required to keep the machines powered on, but you also need to consider what is the amount of power required to keep the equipment cold enough so that it is operating normally. Okay. All right. Good questions. Good participation. I like it. Let us keep this participation going. Okay. And in the WhatsApp group, I will, put some learning exercises. So kindly come prepared. In fact, I can give them to you now itself. So I just want you all to understand and find out from the internet three things. Okay, just three things. Number one, who are the major data center providers in India and the globe? Please make a note of these questions. Who are the major data center providers in India and worldwide? Okay. Second, who are the most famous server manufacturers in this world. Okay, who are the most famous and most prominent server manufacturers in this world? And if you can, try to get certain model numbers and specifications of those servers. Okay, and third thing, who are the most prominent and the leaders in the storage market. Okay, in the storage equipments, which companies are the leading manufacturers of enterprise class storage systems in this world? Okay, and again here, if you can, just get some of the model numbers of the storage systems and their specifications, right? Three questions or three learning tasks. One, identify who are the most prominent and accepted data center providers in India and across the globe. Second, the leaders in server manufacturers and some examples of their model numbers and specification sheets. Third, storage systems, who are the top manufacturers in the enterprise space across the globe, and some examples of their model numbers and the respective specification sheet. Why I am requesting the specification sheet is, if you are able to understand the details that are written in a specification sheet for a given equipment, uh, that itself will give you a lot of idea about the capability of that equipment. Okay, so just like when you want to buy a phone, you go and see all the features, na? What is the battery, camera resolution, okay, your what is it, screen resolution, okay, what and all features it's have, 4G, 5G, this, that, and all. Similarly, every server manufacturer will release something called as a specification sheet for every model of their server. Similarly, every storage system for every model will have its own specification sheet. Okay, on the device specifications, what kind of processors are used, how much amount of memory is there, so on and so forth. Okay, so understanding the models, their features, by reading the specification sheet, it will be much appreciated. And if you can read the spec sheet properly, um, that any customer or data center technology person is expected to know how to read a specification sheet. Okay, so this is the learning exercise for today. Any more questions? Great. Thank you so much, boys and girls, for your time today. We'll meet again, same link tomorrow. And the link I have pinned in the WhatsApp group, so you don't have to search for it. Just click on it and you're into the training. Okay. And this recording, I will upload it on YouTube and share the YouTube link as well, so that you can refer to it later. Okay. But one request, please do not have screen recording on your side or replicate this, because I'm not the one who's going to get into a problem. You are the one who is getting into a problem because of copyright issues. So this content is not my original content. Okay. And hence you may get into copyright issues. Okay. So because I am not sharing it publicly, so you also please don't share it publicly. Keep it for your use only. Okay. All right. Thank you so much, boys and girls. See you again tomorrow in the next class. Have a good day. Bye bye.
Bye, sir.
Bye, sir.